All right, I'm going to give you a quick tutorial right here of solving a systems of equations. So remember, when you have an equation, and if there's two variables in one equation, you can't solve for either variable. And again, on this one, I have two variables in one equation. Again, I can't solve for that variable. But if I put two equations with two variables together, I can solve. And this is called a system of equations. So what we're going to do is try the three methods. I'm actually not going to do the full first method, which is graphing. When you graph it, you need to get those equations, so you graph them. Maybe you get them into slope-intercept form and graph them that way. Maybe use the intercept method and graph them that way. Either method you use, what you do is you graph your lines, and wherever the two lines cross is a point, and that value of the x and the y is the solution to this system. You get an x value, you get a y value. So that's one method you can do. Use your graph and do that. The next two are more algebraic methods that I'm going to walk you through. So the next method I'm going to walk you through is substitution. So the goal for substitution is to take one of your equations and get one of the variables by itself. It doesn't matter which equation it is, so what you want to look for is the one with the least amount of work. So when I look at my two equations right now, I notice that on my second equation here, that x on the left is almost by itself already, so I'm going to choose that one to get by itself. So I have this x plus 2y equals 9. So if I want x by itself, I'm going to move the 2y to the other side, so I do its opposite operation by subtracting the 2y to the other side. It cancels on the left, we get x equals, and 9 and 2y don't join, so I just put 9 minus 2y. Now, that came from my second equation, which means I have to use my first equation now because you have to use the two equations together. So I take the second equation and it has an x in it, and what my first x equals is going to substitute in for what my other x. So I'm going to get 2, I'm going to put a parenthesis so I can hold together all that x is equal to, with close my parenthesis, plus my 3y equals 11. Now I'm going to do the math. So I see a parenthesis, so I distribute. 2 times 9 is 18. 2 times negative 2y is negative 4y. My parentheses over, so I'm done distributing. And I have a plus 3y equals 11. On the left side, I have two like terms there, so I can join those. Negative 4y plus 3y makes negative 1y. You can make it negative 1y. You could just write negative y, your choice. I want y by itself, so now I'm going to subtract this 18 on both sides. I get negative y equals negative 7. And to get rid of my negative, I'm going to divide both sides by negative 1, and I get y equals 7. So I found one of my answers. But don't forget, with every system of equations, there are two answers, one for the x and one for the y. I have my y. The easiest place to get my x is to take this and substitute it right back in where I had my x by itself. So I can say x equals 9 minus 2 times that y of 7. So 9 minus 14. And I do the math, and x equals negative 5. Okay? I can leave it like this, or I could write it like that ordered pair, negative 5 for the x, 7 for the y. So if I would have graphed this, it would have crossed at negative 5, 7. But again, I solved for two variables, the x and the y. That's the substitution method. All right, so now let me switch over and do the elimination method, this third method, the elimination method. It does what it says. It wants to eliminate a variable. So when I look at my two equations, 2x plus 3y equals 11, and x plus 2y equals 9, I want to get either my x's to this numbers are identical in the front, or my y's so they're identical in the front. And just as a hint, I prefer always to have the numbers exactly opposite, one a positive and one a negative. It's easier that way because then I can just add my equations together. Okay, now I'm actually going to do this one a little bit harder than maybe needed so that you can see on a harder example what you might want to do. I'm going to try to make my y's have the same number in front of them. Right now I have a 3 and a 2. Think of like common denominators. What can I turn both of those numbers into? I'm going to choose a 6. So what I do to the top equation is I'm going to multiply by a 2. And the bottom equation, if I multiply the top one times 2, I'll get a positive 6y. So if I multiply the bottom one by negative 3, I'll get a negative 6y. And those will make opposites. Okay, so there's my decision what I'm going to do. Now I'm going to do the work and see what happens. So when I distribute, I have to distribute it to everything in the equation. So 2 times 2x will give me 4x. 2 times 3y will give me 6y. And 2 times 11 will give me 22. I have to take it times everything. The same on the bottom equation, this negative 3 is going to go to everything. So negative 3 times x is negative 3x. Negative 3 times positive 2y is negative 6y. And my equal sign, negative 3 times positive 9 is negative 27. Now that I've done that, I'm going to add my equations together. A 4x plus a negative 3x is just 1x. Positive 6y plus negative 6y, there's where they eliminate. They're opposites, so the whole term goes away. There's no more y at all. Make sure that you have those opposite signs to get that to do that. My equal sign comes straight down, and 22 plus negative 27 is negative 5. I really don't need to divide by my x or that 1, so I just know that x equals negative 5. I have my x, now I need my y, because every time you solve a system of equations, you need an answer that's an x and you need an answer that's a y. Your choice where you plug it back in at. I think that it looks easiest to plug it back into this equation here that I used before I multiplied times my negative 3. And it doesn't matter, you can plug it into any one of those equations and you should get the same answer. So I'm going to get x plus 2y equals 9. I'm going to plug in my negative 5 for the x, and I'm solving to get the y by itself. So I'm going to add 5 to both sides. I'm going to get 2y equals 14, divide by 2, and y equals 7. I know I'm running out of space there. And if you peek at what I got for substitution, what I got for elimination, I got the same answer. I should. It's the same system of equations. And once again, if I want to, I can write it as an ordered pair. Negative 5 is the x, 7 is the y, and there's my answers for this system of equations. Every time you have a system, you should get 2 answers if there's 2 variables. Let me know if you have any questions.